Let's move on to question 6 of Mathematics Paper 1 of June of 2024. The graphs of fx equals to x squared minus 2x and gx equals to mx plus c are drawn below. D and E are the x-intercepts and P is the y-intercept of f. The turning point of f is t1 and -4, and the graphs of f and g intersect at P and E. Now, before I attempt the questions, I would like to fill in the information on my diagram. So I know that fx is equals to x squared minus 2x minus 3. The equation of gx was given as mx plus c. We know that P and E are the intercepts and that the coordinates of t is 1 and -4. Question 6.1. Write down the range of f. So the range is all the y values for this graph, and I can see that the graph is above -4. So for 6.1, the range is y is bigger or equal to -4. 6.2. Calculate the coordinates of D and E. So the points D and E are the x-intercepts of the graph of f. So we know that at the x-intercepts, y is equal to 0. So we'll have 0 is equals to x squared minus 2x minus 3. And that's an easy trinomial to factorize. So if I split the factors of x squared, I have x, and the factors of 3 is 3 and 1. And I'm trying to create -2 in the middle, so my signs would be -3 and +1. Now if I solve for x, I have x is equal to -1, or x is equal to 3. But the question said, calculate the coordinates of D and E. So you'll always want to leave your answer as coordinates. So for D, we have x of -1 and y is 0. And for E, we have x is 3 and the y value is also 0. Now before we continue, I'd like to put that information on my diagram. So I have D as -1 and E as 3. Question 6.3. Determine the equation of G. So we have G is equals to mx plus c. And I can see I can find the c value if I can find the coordinates of P. Now P is the y-intercept of fx. So let us start there. Let's find the coordinates of P. So I'll make x equals to 0 in our fx equation. So it's 0 squared minus 2 times 0 minus 3. And that is equal to -3. Therefore, the coordinates of P is 0 and -3. So therefore, if I have our straight line as y is equals to mx plus c, we have our y-intercept, which is c, as -3. Next, we want to find the gradient of this line. So we can find the gradient by using our gradient formula and using the points E and P. Alternatively, we can substitute x and y with the coordinates of E. So at E, y is 0, x is 3, and we have the y-intercept. So if I simplify, I have 3 is equals to 3m. Therefore, the gradient is equal to 1. So my equation of the line, we have gx is equals to mx plus c. So m is 1 and c is -3. We can also write it as x minus 3. 6.4. Write down the values of x for which fx minus gx is bigger than 0. So if I take the inequality of fx minus gx bigger than 0, I can write it as fx is bigger than gx. So I simply move the gx to the right-hand side of the inequality. And if I look at my function, I'm looking where is fx above gx, and you can see it's to the left of point P, and also fx is above gx to the right of point E. So the x value here to the right of E is x is bigger than 3, and to the left of P is x is smaller than 0. So therefore, x would be smaller than 0, or x would be bigger than 3. Notice I'm not writing this as one inequality, but I'm writing it as two inequalities because I'm going in different directions. 6.5. Determine the maximum vertical distance between h and g if hx is equals to negative fx for x between negative 2 and 3. So for 6.5, what I would like to do is first find the equation of hx. And that's simply negative fx. So I take fx and I change all of the signs of every term. So that is multiplying the whole equation with negative 1. So what I realize is that hx is the reflection of fx about the x-axis. So let me draw a rough sketch of that graph in. So it will go through point D and E. And the question says, determine the maximum vertical distance between hx and gx. So can you see in our graph, if I draw in a rough sketch of hx or h, we're trying to find the maximum vertical distance between h and g. So that's the straight line. And it gives us a restriction. It says where x is between negative 2 and 3. So we can see that this 3, the upper limit, is already that point of intersection. So I'm guessing that the x value here at our point of intersection on the left would be negative 2. So in order to find the maximum vertical distance, we would need to find the distance between h and g. So that distance can be represented as hx minus gx. Notice I'm putting hx first because that's the graph above gx. So I'm subtracting gx from that. So let me substitute the equations in. So hx is negative x squared plus 2x plus 3 minus gx, which is x minus 3. And notice my use of brackets because I need to subtract the full line. So I have a new equation for the distance or the vertical distance, and that is negative x squared plus x plus 6. So when I simplify, I have negative x squared plus 2x minus x, that becomes plus x, and then plus 3 minus minus 3, which becomes plus 3, and that's where the plus 6 comes from. Now, if I want to find the maximum distance, I'm going to use calculus. You can also use completing of the square. But if I take the first derivative, that becomes negative 2x plus 1. And to find the maximum distance, it's where the first derivative would be equal to 0. So I'm solving an x value. So if I solve for x, I have x is equal to a half. Now that half does not represent the maximum distance. It represents the position at which the maximum distance is. And that is where x is equal to a half. Now to find the maximum vertical distance, I take my distance formula and I substitute x with a half. So it's negative a half squared plus a half plus 6. And when I simplify that, the maximum distance would be 6.25 or 6 1/4. Question 6.6. Given that kx is equals to gx minus n, determine n if k is a tangent to f. So let us start by finding kx. So we know that kx is equals to gx minus n, and the equation of gx is equals to x minus 3. So therefore, the function of kx is equals to x minus 3 minus n. Next, we are given information that k is a tangent to the curve of f. And I want to find the value of n when k is a tangent to the curve. So what I realize is that the line of k would be parallel to the line of g because they have the same gradient of 1. And what I can try and do is use the gradient that is equal to 1 to find this point of intersection. So when I have found this point of intersection, it will allow me to find or to have a y value and an x value on the line of k, which will allow me to solve for n. So if it is a tangent to the curve, we know that the gradient is equals to 1, but we also know that fx is equals to x squared minus 2x minus 3. But gradient can be represented as the first derivative. So the first derivative of fx is 2x minus 2. And we know that the gradient of k is 1. Therefore, the gradient of the tangent to the curve is also 1. So 1 is equals to 2x minus 2. And now I can solve for x. So that becomes 3 is equals to 2x. Therefore, x is equals to 3 over 2. So at this point of intersection of k to the graph of f, we have x is equals to 3 over 2. Now I need to find the y value. So in order to find the y value, I can use the equation of fx and substitute that x value in the place of x in this equation to find the y value. So we'll have y is equals to 3 over 2 squared minus 2 times 3 over 2 minus 3. And that means that y is equals to negative 3.75. So you can use your calculator. And now we have the coordinates of a point on the line of kx. So we have a y value and an x value, which we can substitute into our equation of kx. So we have kx is y equals to x minus 3 minus n, where the y value is negative 3.75. The x value is 1.5, so it's 1.5 minus 3 minus n. And then I can solve for n. So that becomes negative 3.75 minus 1.5 plus 3 is equals to negative n. So negative n is negative 2.25. Therefore, n is 2.25. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.